Greetings there, awesome physics students. I want to talk about acceleration, in particular the sign of the acceleration, that is whether it's positive or negative, and also the meaning and the units. And the meaning and the units go together. The units tell you what the meaning is, and so we'll get to that here. I want to start with an example. Imagine you're in a car and you put it in reverse and you drive backwards at constant speed for 2 seconds at -5 meters per second, and then you hit the brake and you come to a stop. Okay, so let's draw the motion diagram for such motion. You begin here and you travel at constant speed for 2 seconds, so you travel equal distance in those 2 time intervals. And then you put on the brake and you begin to slow and come to a stop. Okay, so the motion diagram is going to look something like that. Let's draw the velocity time graph for this motion. And note that let's choose this direction to be positive. So that way is positive. So it makes sense to be in reverse, and that's negative. So you're going to be traveling at a -5 meters per second for 2 seconds, constant speed. And then you put the brake on and you come to a stop. Well, coming to a stop is 0 velocity. That's here. You need to get to that point, so you need to go, the graph should go like that. Okay, so of course during this motion here, the acceleration is 0 because the slope here is 0. Remember that the value of the acceleration is the slope of the velocity time graph. But here the slope is positive, so that implies that the acceleration there is positive. But you're slowing down. Doesn't positive acceleration mean speeding up? How is it that I have a positive acceleration and yet I'm slowing down? That seems counterintuitive and wrong. Well, let's look at the motion diagram to see if it agrees with this. This will give us a clue on what's going on here. Remember that the velocity vectors point along the displacement like this. And so let's look at 2 velocity vectors here. Let's look at the velocity vector here. That's the initial velocity, and the velocity vector here, that's the final velocity. I want to know what the change in velocity is. Remember that the change in velocity over time is the acceleration vector. So if I know the direction that the change in velocity vector points in, I will know the direction of the acceleration vector. So I need to take final minus initial here. So I'm going to start with final, and then I need to take initial and flip it. And so I'm going to start, remember, if I'm taking final minus initial, so that's initial, and I flipped it and put it here, then that's -v initial. Then my delta v, or my change in velocity, will begin where I began, which is here, and end where I end, which is here. So this is the change in velocity vector. Well, that also points that way, which we define to be positive. So it seems that the motion diagram and the graph are both telling us that the acceleration is positive. So what's going on there? Doesn't positive acceleration mean speeding up? Well, no. The acceleration, the meaning of the acceleration is it tells you which way the velocity is changing. So if I were to get the change in velocity here is a positive 5 meters per second, right? The velocity went from 5 to 0. That's an increase of 5, not a decrease. And so the acceleration then must be equal to, if that occurred over 1 second, the acceleration must be equal to 5 meters per second each second. So here we come to the units that I was referring to. The units of acceleration are meters per second. Sometimes people write it as meters per second squared, because if you combine the 2 seconds, you'll get it squared like that. But I think it's better to leave it like this. And the reason I think it's better is because this reminds you of the meaning of this. This tells you, this is a positive number now, by the way. This tells you that each second the velocity is changing by positive 5 meters per second. In other words, every second I add 5 meters per second to the velocity. If I began at -5, that means I'm going to get to 0, and that means stopping. In general, the way that you know if something is slowing down or speeding up is the following. If the velocity vector and the acceleration vector point in the same direction, no matter which way it is, the object will be speeding up. If the velocity and the acceleration point in opposite directions, no matter which way they point, it will be slowing down. So positive acceleration does not mean speeding up, and negative acceleration does not mean slowing down. You have to think about which way the velocity vector is actually pointing to figure that out. What the acceleration vector does tell you is which way is the velocity changing. Which way does the delta v point? Is the velocity becoming more positive or is it becoming more negative? Okay, so that's the sign, the meaning, and the units of acceleration and how they're related.